Oh, welcome back. And we're here taking a look in Colab. Usually we're always using GPUs, but today we're not using a GPU. So CPU only today, no need for high RAM. All right. And what we're going to be doing, if I just zoom in here. So what we're going to be doing is we're going to be installing a whole bunch of things. These are cool Python libraries which can be used to calculate and generate simple images. So no GPU image generation. I was actually thinking that these could be used as input maps to then run Diffusion on to get some more interesting, use style Loras on basic generated shapes. So we generate an image to transform. That's the idea anyway. But I just wanted to have a little bit of an exploration of what we could actually do. So again, you're going to find this notebook in my GitHub, and you will find a link for that on the 5below5.uk website. Okay. There's an archive for all these videos. You'll be able to find the episode name, and anything which I talk about will be right there. So this is PyKandinsky. The concept was inspired by watching someone talking about Gemini on YouTube. And he was like using a text prompt to generate this. You basically said, make me a Python art generator that emulates Kandinsky's style. Okay. It's an older artist, so apparently it's public domain. I don't know. My point is, it's just circles, lines, and arcs in randomized colors at randomized locations. So if you're familiar with a bit of code, you should be familiar with the code here on the screen. So let's run it. So we're going to be getting Pillow, Matplotlib, NumPy, Skippy, Artree, and TriMesh. Pronunciation may vary. Okay, so now we've got our dependencies installed. Let's take a look at the code that Gemini gave us. So the code Gemini gave us was okay, and it did require a lot of work to fix. All right, I'm not going to lie. The problem we had was it wasn't generating in the middle of the screen. So if I just quickly disable the canvas save, so it looks like that. So the problem was, of course, it's all generating on one side, which is crap. So there was a problem with this code. Got it to a point where it was actually working, but it was a bit boring. You know what I mean? What I thought was, oh, maybe we can improve it by making it more central. And the short story is not really. I think what it did was it just kept breaking. Trying, bless it, but most of it is just stuck in the left side. So I was thinking to myself, so I kept showing the errors and giving requests to Gemini. And I kept on asking him, come on, mate, I believe in you. And he's not a bad AI, Gemini, but he didn't really get it. Okay. And you could say, well, maybe I was asking it to do silly things. And, you could be right. There could be some truth to that. But ultimately, it did work. These are all the ones that worked, but didn't produce good images. See, that was the thing. It's like if you give it a goal, see, most of the stuff is generating off screen. The reason I've took the time to show you all of that is because as a one-shot tool, given this task, yes, it did work. Okay, it did work. One of the early images was fine. All right. But here's the thing. Let's do it with GPT. It gets it in one. That's the difference. Okay, it's not perfect. The final layer was a giant square. So I decided, well, that's cool and all. But I want to be able to control it, right? So what it does is it's going to concatenate all the XY values into a really long string. That's all we've done down here. So here it is. So that's pretty good. That's usable. And the interesting thing is, as I say, the file name it's not really a seed. It's actually defining exactly what location everything is, but the colors should still randomize. So, it won't produce the exact same image, but it will make the same compositional layout because it's just basically randomly colored shapes, right? And so then I thought, well, hang on a minute. If we've now got exposed values, well, what if we allow the user to give a string? Okay, so now the user comes along, puts a string of numbers in, or just generates a random string of numbers, I guess. That might break, though. It might be that you have to have a size over 1000 by 1000 for it to work with any combination, because obviously how do you know whether it's 2 digits or 1 digit? That could probably break it. There's lots of ways to break it, but the point is, string of numbers in that sort of sequence, it's going to make Kandinsky from coordinates. So then, you know, there's a way that you can potentially drive what you get, is what I'm saying. So the file name ends with the instruction for generating it. So that was pretty cool. And then, like I said, the final version of that puts them into a more manageable sort of format, you know. So it's not just a super, you got X's and Y's. This is a 1280 width and it's only producing them in that area there. It's not a bad thing, but you can see how it's built from the top left. Then I thought to myself, well, hang on a minute. And like I said, this code is all going to be in this notebook. You'll be able to go and get it. So, and you can copy it, put it in your projects, whatever you want. So now we're going to take a look at some other stuff I ended up doing. So if we take a look at, we got random triangles, but there you go. It makes random triangles. And every time you run it, it gives you random triangles. Okay. I've even put a seed in here. So that was something which we built in an actual seed thing. So like if I change this to an 8 and run it again, we're going to get another file with another name, and it's a different image. So all it does is make randomly colored triangles. It's not complicated. Next one, we take a zoom in of a fractal, we mirror it twice, and then we apply a gradient from white to dark gray. And then what that does is it just gives us a cool mask. Like I said, this is pretty cool. I believe is there a seed for this one, or is it just random every time you click it? Zoom X, zoom X min and max, and zoom Y min max, and then zoom iteration. So you've got controls here if you want to actually alter the edge of the fractal that's been zoomed in on for this. Not very intuitive, but I just wanted to see if it could be achieved, really. So there it is. So I wanted to have a go at branching trees. So this will do that. It'll make a little tree branching structure. So in we go. And there's your moire pattern. And obviously we've made it so we've exposed parameters. I've given it a file name. So we can change the image size, offset, line distance. That's all you really need for that pattern. It's just simple geometric stuff. All right. Again, so this is just concentric circles, right? So I believe there's a way to make it so that it will fill them, but I thought it looked better as just lines. Okay, maybe you could run it through Sketch or Canny, maybe. Because I'm thinking about these as like guidance maps for making abstract art with art generators rather than just people and places, you know. So there we have a particular pattern on this side, we have a particular pattern on this side, we have a pattern on this side, another pattern on this side, and then they all overlap, is what's going on there. And then you've got a bleed area, basically. You could just tile that, but you can actually tile this. It will overlap with an offset. And then we start getting into 3D stuff. Let's just get into it. So basically, there are ways to use Matplotlib with Axis 3D, and it's possible to parametric PNG. There we go. So obviously, this is a 3D model made with some math, and there's an OBJ which I've tried. You can load them. They're good, right? And so, yeah, that's the last one that I did. So you have control over the phase, the frequency, that's the actual So these two values are actually the model, what the geometry is that's being generated. And then these are a bit more about how the polygons all attach. Like if you have crazy amplitude, it'll be really rough, you know, and so on. Let's start at the beginning. So the first geometric shape we generated was like this. Then what we did was we implemented a little bit too much, a little bit more noise. And then I basically put that the scale up. So this is like much, much bigger. And then we increased the amplitude far too high. And then we turned it back down again, but kept a little bit there. And then this is the one that's in the code right now. Okay. So that's pretty much what's going on there. All right. So yeah, with that, basically, we're able to generate 3D models with code. And I know this isn't a new thing, all right? It's not new. But the point is that ChatGPT wrote this. You know, I didn't write it. I asked it to write it to see if it could write it, and it could write it. So don't be afraid. Get stuck in. If you have an idea, ask it to make it. And in future tutorials, I will take you through how you can take that code and put it into a project and run it and test it and make it better. And then you can use it as your own private tool. So there you go. Thanks for coming along. 5below5.uk. See you next time.